Now, continuing with a typical triangle, and like with other polygons and the circle, the triangle has an interior side, an exterior side, and the triangle itself. For example, in this triangle, point A is inside the triangle, point B is outside the triangle, and point C is on the triangle. So if I say from point P in triangle ABC a line is drawn to vertex B, I'm referring to a point inside triangle ABC. And if the sentence changes to from point P on side AB of triangle ABC to vertex C, then point P is part of the triangle and is neither outside nor inside the triangle. Okay, let's get now more specific. We already said that an equilateral triangle has three equal sides. Again, notice the use of tick marks to show which sides are equal. And of course, because the largest side of a triangle is always projected by the largest angle, and the smallest side is projected by the smaller angle, then it makes sense that if all the sides of a triangle are equal, then the three opposite angles must also be equal. Notice how tick marks are used to show also which angles are equal. Something similar also happens when you draw an isosceles triangle. If two sides of a triangle are equal, like in the case of an isosceles triangle, then the angles opposite those sides are also equal. Now, a triangle has 180 degrees. As a matter of accuracy, all triangles have 180 degrees. Why? At the end of chapter 4, which is the chapter on parallel lines, you'll find a very explicit explanation on why all triangles have 180 degrees. But for those of you who are not ready yet to handle a proof, then you're going to have to trust me that all triangles have 180 degrees. Okay, if in an equilateral triangle all angles are equal, then each angle is 60 degrees because 180 divided by 3 is 60. And while we're still at it inside a triangle, let's say that if one of the angles in a triangle is 90 degrees, or a right triangle, the other two angles must be complementary, because by definition complementary angles add up to 90 degrees, and that is exactly what is left in a triangle that has one 90-degree angle. Notice here that you cannot have two 90-degree angles in a triangle. How could you? If two angles at 90, there is nothing left for a third angle, so it is impossible. So if one angle in a triangle is 90, then the other two must add up to 90.